This lesson is going to be about atoms and chemical reactions. The learning target is to be able to know what happens to atoms during a chemical reaction. Now, when we have a chemical reaction, what's going on in there is we've got atoms of one or more substances rearranging to form one or more new substances. So we have the same atoms before and after. They're just arranged differently and bonded in different ways afterwards of our chemical reaction than they are when they started. If you look over on this left side here, we've got one carbon atom right in the middle here, but it's bonded to 4 other hydrogen atoms. So this is called methane, CH4. On the right side here, we've got our carbon atom right in the middle here, but it's bonded to 2 oxygens. This is CO2, or carbon dioxide. These are 2 completely different compounds and 2 completely different substances. We've still got our 4 hydrogens over here. So they're still around, they're just bonded differently on the right side of our reaction as opposed to the left side of our reaction, before and after our reaction. And so because they're bonded differently, we have completely different substances before and after a chemical reaction. And this rearrangement is very important. So when atoms rearrange to create one or more new compounds or new substances, that is what's going on in a chemical reaction. And so just to remember some of these signs of a chemical reaction before we get way too into this, we have a change in color, forming a bubble as long as it's a new gas, forming a precipitate, some sort of solid when we mix 2 liquids together. A change in odor would definitely be a sign of a chemical reaction. Warming or cooling, which we'll talk about later in this unit with our endothermic and exothermic reactions, or if light's given off. Right? So these are some signs of chemical reactions, ways that you could know that a chemical reaction is happening. But remember that the number one way to know, and the way that you would check some of these, is that a new substance is formed in our chemical reaction. So what's actually happening during a chemical reaction? In a chemical reaction, the original bonds are breaking. These atoms are rearranging themselves. In the first example that we had, our CH4, all of those bonds that were connecting the carbons and the hydrogens broke, and the atoms rearrange to form new compounds on the other side. And so once they rearrange, new bonds form, and the atoms form new substances, these new compounds together. So that is what's happening during a chemical reaction. We're going to look at an example of this right now. So if I have my CH4, my methane, and my oxygen, right, we put energy in to break those bonds, see how they're separating out. Same thing happens with our oxygen. Energy goes in, and those bonds break apart. Now we've got individual atoms that are ready to bond again with other atoms and form new substances. And so our atoms rearrange, and these new bonds form with our hydrogens, 1, 2, and our oxygens. And so we get H2O. And the same thing happens with our carbon dioxide here. Notice that we had the same exact atoms before as we did after. They just rearrange with each other. And that's a really important point here. And also notice that we didn't gain any new atoms, or we didn't lose any of the atoms that we started with. We began and we ended with the same exact atoms throughout our chemical reaction. That's an important point here, is that the atoms are not gained or destroyed, lost or destroyed. That should ring a bell there, or something with energy. So a chemical equation is a way that we represent our chemical reactions. And this is a description of a reaction using element symbols, which you have learned, H, S, Ca, and chemical formulas, where we have our compounds shown here, which you've learned about in covalent and ionic compounds, whether it's H2S and CO2. Now there's 2 different numbers that we could have here, right? The number of each molecule, which is this number out in front here. Remember, this 3 means that I have 3 of these H2 molecules, and this is called a coefficient, this number right here. Number of each molecule is called a coefficient. And the number of each atom is these little subscripts down in here. So within this molecule of H2S, I have 2 hydrogen atoms and 1 sulfur atom. And that's our subscript that tells us that number. Remember that if there's not a number down here, that's a 1. We have 1 sulfur. And so in this molecule here, I've got 1 carbon and 2 oxygens. So if I look at my chemical equation here, this would tell me I have 1 molecule of N2, 2 nitrogen atoms together. In this one here, I've got 3 molecules of H2, 2 hydrogens bonded together. And in this one, I've got 2 molecules of NH3, 1 N, nitrogen, and then 3 hydrogens all bonded together. So that's how we read our chemical equations in that way, with those 2 numbers. So just some notes on writing chemical equations. We'll get better at this as we go. But we've got two different things we've got to keep track of. We've got our reactants, which are the starting substances in a chemical reaction over here, and which would be our left-hand side here on the left-hand side of the arrow. And then we've got our products, the things that are made by our chemical reaction. Those are over on the right-hand side of the arrow, our 2NH3. That would be the things that we are making in here. And so you're going to want to remember that, reactants and products here. And so the last thing that we've got to leave you with is the law of conservation of mass, that part where it kind of reminds us of the law of conservation of energy, where energy can't be created or destroyed. It's the same thing with our atoms in a chemical reaction. We can't create or destroy atoms within a chemical reaction. We are only rearranging the atoms that we already have. So when we make a new substance, even though it might seem like we made something out of thin air, we probably got something from the air, the atoms that showed up, and now they've formed a solid. It doesn't have to be just air, but whenever it looks like we're forming something and we're making something that wasn't there before in a chemical reaction, we should be thinking about where those atoms came from. They probably came from the air. They might have came from the another part of the environment, but we cannot create or destroy any atoms in here. So whatever atoms I start with, I have to end up with those exact same atoms. And that means that the mass of my substances have to be the same before and after. So if we weighed everything, it would be the exact same. So that is your lesson on what the atoms are doing in chemical reactions. I hope that helps. Big ideas are that they rearrange in a chemical reaction. We can't gain or lose any, and we start with reactants and end up with products. So I hope that that helps with this lesson.